ECAB, what can you tell me about that line?
It's in standard form.
Good, it's in standard form. Do you have any idea what the slope is? Could you find it? How?
I would set everything equal to 4y and then divide it by 4.
Beautiful. So you could go and find the slope if you needed to?
Yeah.
Okay, great. But that's a line. Is that line horizontal or vertical?
Horizontal.
So the answer is no, it's neither horizontal or vertical. How do I know that it's not horizontal or vertical? Anybody? Charlie?
Is it because there's nothing in front of the X?
Say again?
Is it because there's nothing in front of the X?
Nope.
X and y both have a value.
Good. You have an X and a Y. So if it was vertical, it would have only an X. If it was horizontal, it would have only Y. So this is just a plain old line. Okay? It's either got a positive slope or, what kind of slope it has we don't care about. But what we're going to do is we're going to take that puppy and combine it with another line. And put a fancy brace in front of it. That second line, is that second line horizontal or vertical? Neither. Okay, so it's just some other line. Which means now, by putting the brace in front of it, we're going to be solving a system of equations. And what a system of equations does is that when we're done, we're going to know exactly where those two lines intersect. Because they have to intersect somewhere. Theoretically. How do we do that? Do you remember this from last year?
Kind of.
Kind of. Well, there's two methods that we can use. We'll do the first one using the substitution method. Then we'll also talk about something called the elimination method. And I think this will start coming back to you as we work through them. A lot of times I'm not going to put a restriction on you and tell you solve it using this method, solve it using that method. I'm just going to let you choose whatever one you want. So, I've got a couple different options to solve this problem. I could solve the top equation for x, plug it into the bottom equation. I could solve the top equation for y, plug it into the bottom equation, and I can repeat that with the other equations. What I'm not going to do in this case, however, is solve the top equation for y, because if I do that, I'm going to get some fractions, and I want to avoid fractions whenever possible. So that means I think I'll solve the bottom equation for y. So the bottom equation becomes x minus 7. And then take this stuff and plug it into the top equation. You can't plug it back into itself. So therefore the top equation becomes x plus 4 times the quantity, those parentheses are very important, equals 8. Is this equation in red now solvable?
Yes.
Yes. How many equations do I have? In red. 1. How many variables? 1. Therefore it's solvable. Okay. Then we'll go back to the other one. X plus 4x minus 28 equals 8. 5x is equal to, add 28 to both sides is 36. Yes? Why do I feel like I screwed up there somewhere? I'm good, right? My math check out? Okay, that's not a very pretty answer. I'd expect a nicer answer at this point. But we'll go with it. How do I find y? Does it matter where? No. I can pretty much plug it in anywhere. You probably want to plug it in somewhere easy. Like I would do it probably there. And then that would give you y. Okay. So that one doesn't turn out so nice. Let's try another one that has a prettier answer. Initially, we're going to be solving problems that do have pretty answers. But starting Thursday, we'll start looking at problems that don't have pretty answers, and you'll be using your calculator more to find the answers. Gesundheit. All right, we're going to do substitution again. Which variable do you want to solve for? X on the top, Y on the top, X on the bottom, Y on the bottom. X on the top, we all agree, because that's the one that has no coefficient. So the top equation becomes X equals 2Y minus 6. Take this, plug it in right there. 4 times parentheses, very important. Oh, that's a nicer answer. 2. Take 2. Put it in there. X is equal to 2 times 2 minus 6. X is equal to negative 2. Since we're solving for the point of intersection between two lines, your answer should be in the form of a point. Negative 2, comma 2. Question?
So when you made that second, like right here, why did you not have it as negative 2y? Because in the first.
Oh, I couldn't, because I plugged it into the red one that's circled.
Yeah.
I could have plugged it in up at the top too.
Oh.
So, and I'll show you what that would look like. I could have taken this 2 and put it in all the way up here. So there I would get X minus 2 times 2 equals negative 6. So that would give me X minus 4 equals negative 6, so X would be equal to negative 2. Same answer, just a different way to do it.
Okay.
I could have also plugged it in here, but I think you'd see that that would be kind of nasty. Okay, you have a lot of options where you want to plug it in. Got it?
Why can't you plug it into like the X in its own problem?
Initially,
Yeah, so why couldn't you just do 2y minus 6 plus 2y minus 6?
that's a good question. I'll show you what it looks like if you do that. And this will be an indicator of something's going not quite as planned. So if I take this and put it back into where we got it from, you would get 2y minus 6, that's the x value, minus 2y equals negative 6. Those cancel, negative, yeah, the x's disappear, or the y's disappear. So you got to put it into the other one. Okay, that's the substitution method. Some people like it. I'm not a fan. I'll show you the second one that I'm sure you've done before. I like the second one better, but again, this is America. You can use whichever one you want. Like the power right on. So let's take a look at the other system called elimination.
But what was the first system called?
Substitution. This is coming back to you, right? Or it's already back. I mean, you can do this, right? Okay. In the elimination method, you're going to eliminate one of the variables. You have to decide which one you want to get rid of. Do you want to get rid of X? Or do you want to get rid of Y? Peter, which one do you want to get rid of, X or Y?
Y.
Y, great. The nice thing about this is there's no wrong answer. Peter might decide he wants to get rid of Y, which he already does. Somebody else might decide they want to get rid of X. Doesn't matter. What does matter, however, is what you choose to multiply each of these equations by. All right, Peter, if we're going to get rid of the Y's, what do I want to multiply the top equation by? You remember this?
No, I don't know.
Okay. Somebody help him out, other than Daniel. Trying to think of it. Sorry?
Greatest common factor.
So what do you want to multiply the top one by? Here's the thing, we can multiply the top equation by a whole bunch of different possibilities. The interesting thing here is, we don't care what you multiply the top one by, well, we do in some respects. But as long as when we're done, the coefficients in front of the y values are the same number, different signs, we'll be good to go.
Well, if you multiply the top one by 2 and the bottom one by 3.
Perfect. The easiest thing to do usually is multiply by the other one. So multiply this by 2, multiply this by 3. Will that give me a positive coefficient in front of the y?
Yes.
In this one? Will it give me a negative coefficient in front of the y on this one? Yes, beautiful. 8x plus 6y is equal to 16. You have to multiply everything by 2, not just the variables. The bottom becomes 3x minus 6y equals 26. Question?
Why do you multiply the top one by 2 instead of negative 2 with 3 and 36?
Because if I multiply the top by negative 2, I'd have negative 6 and negative 6, and they have to be opposite signs. You'll see why in a second, because we're going to add them, and we want them to drop out.
You multiply 13 by 2 numbers.
Good catch. I did that just to see who was paying attention. Kelly?
So only one of the variables has to like be equal to each other in order to
Correct. Yeah, if they both equal each other, we got a whole bunch of problems. Okay? And I'll do this one again using a different technique after I finish this. Let's get an answer here. Now we add. And I don't know what you learned last year. I have heard that some teachers teach it using subtraction. It's a bad way to go, because everybody makes mistakes with subtraction. Addition is so much easier. 6y's cancel out, which is good because we want to get rid of a variable. 8x plus 3x is 11x. 16 plus 39, 55. So x is equal to 5. Now, where do you want to plug that back in? You've got a whole bunch of different choices. You actually have 4 choices. I'm going to put it into the second equation from the top. Take this, put it in up there. I get 5 minus 2y is equal to 13. Negative 2y is equal to 8. Y is equal to negative 4. Therefore, my final answer is 5, negative 4. Now, this is a quiz question. I get done early, I've got some time. How do I know that's the correct answer? I heard somebody say it. Plug them back in. If I plug 5 and negative 4 into the top equation, it should work. If I plug 5 and negative 4 into the bottom equation, it should work. Let's do magenta. Okay, everybody have this? Because I want to erase and do this problem again, showing you the other way to do it. Or one of the other ways to do it, I should say. So if I go back to the very start, get rid of this. Okay, so what Peter did is perfectly fine. No problems. We can also do the other one. If we want to get rid of the x's, I'm just going to multiply the bottom equation by negative 4. This isn't necessarily easier, it's just a different approach. So the bottom equation becomes negative 4x plus 8y equals negative 52. Add. 4x cancels with the 4x. 11y is equal to, where am I at? Negative 52, negative 44. Y is equal to negative 4. Was that my answer from before? It better be. Yes? Okay, good. Then take this, plug it back in, and by the magic of math, we get y, or x being 5. So, same results, different approach. Are those the only 2 ways you can do it? No. I can multiply the bottom equation by 10. No, sorry. Top equation by 10, the bottom equation by negative 40. That would work. I can multiply the top equation by 15 and the bottom equation by, let's see, it'd be 45, 22 and a half. I mean, there's all kinds of possibilities there. As long as when I'm done with the multiplication, the two coefficients in front of one of the variables cancel out. Okay. All right, you try this one then. So if you're given this problem on homework or on test or on a quiz and it doesn't tell you what method to use, hopefully you would recognize that this is an elimination problem. Could you do it using substitution? Yes, but it would be ugly because you'd have to solve one of those variables, and since they all have coefficients, you would have some ugly, ugly fractions.
For elimination, could you ever divide to get the lower number?
Say again?
Could you ever divide?
I mean, mathematically, it is okay to divide both sides by a number. What were you thinking in this particular case? I mean, you could take the top equation, divide by 2, take the bottom equation and divide by -3, but then you get some gross, disgusting fractions, which would make you throw up a little bit.
Are there any problems that would be better to solve substitution?
Better is a relative term. I mean, I know that's a cop-out answer, but it's all a matter of what works best for people. Some people, I mean, it's like the slope-intercept versus point slope. Some people will not give up slope-intercept. They just love it to death and they'll use it all the time. The same is true here. I always try to use elimination just because I like that method better. But there are problems where elimination is the problem because I got to do a bunch of prep work to get all the X's and Y's lined up. You get big numbers, but it works. Be bashful about busting out those calculators, kids. Especially after grading some quizzes. A lot of mistakes on the quiz were simple things like 2 + 3 is 6. Come on, man. Did you get your 7 forms yesterday? You're like that guy from the Bills that retired at halftime. Anybody hear about that?
Humphrey Davis.
Yeah. Buffalo Bills are so bad, this player retired at halftime. It's like, I've had it, I'm done. I haven't done this yet, but hopefully the answer turns out to be nice. That's how you guarantee you can't. And then you gotta change all of them to those names, so that should be positive. And then make your number a little bit negative too, because you're gonna multiply everything by negative. Okay, what's interesting is that walking around the room, I'm seeing people do it all kinds of different ways in the numbers that you're choosing to multiply by. Some of them are generating big honking scary numbers, which are fine as long as you get your final answer. You can plug it back in wherever you like. Wherever it's going to be easiest. I usually go back to one of the original equations. That's my ninja skills. Okay, then at the time.
13.6. I got 2.8.
Positive 16, negative 16.
How'd you do that?
See?
Oh, it's,
I put something in wrong here. How do you
Okay,
do
good. No, should be a nice answer.
Oh, I know what I did wrong.
That's when you get your, what do you have for?
I know what I did wrong. So you did, and then this one by. So then, oh god, it's huge numbers.
It's looking like 7-6 is the ongoing answer here. Okay. If you got 7,6, that's great. If you didn't, the question is, what did you do wrong? So some mistakes I saw walking around the room is remembering that if you choose a number to multiply by, you got to multiply everything by that number, including the sign. Okay? So let's take a look at some possibilities here. What did you multiply the top and bottom equations by? Hopefully you realize I can't just multiply one of them by a number because things won't cancel off. Trace, what do you got?
I multiply the top one by 3 and the bottom one by -2.
Okay, good. So you're going to eliminate the y's. We'll come back to that in a second. Anybody choose different numbers?
I chose -8 and 7.
To get rid of the x's.
Yeah.
Good. Others? Charlie, what did you do?
I did negatives, like I did times 15 on top, then times 10 on the bottom.
Negative 10.
Oh, negative.
Yeah. Okay, so he went for the big daddy and said, all right, these are opposite numbers. I'm not even going to play with least common multiples or LCM and MCR and all that other garbage. I'm just going to multiply both. Still works. He just got big numbers. Well, who cares? He's also got a calculator. Okay, did you get it?
Yeah.
All right, so let's go with this one then. Multiply everything by 3. I get negative 21x plus 30y equals 33. And 16x minus 30y equals negative 68. I'm good so far, right?
Yeah.
Okay. That's negative 5x. Those cancel. Negative 35.
Yeah.
So x is equal to 6. No, it's not.
No, it's 7.
Good, I was just seeing who's paying attention. Good job. I can teach calculus, I just can't do simple addition or division. Take this. Grace, where'd you plug that in?
The first one.
First one. Bring this all the way up here. Negative 7 times 7 plus 10y equals 11. Negative 49 plus 10y equals 11. 10y is equal to 49 plus 11 is 60. Y is equal to 6. Yeehaw! 7 comma 6 in parentheses. Pregunta.
For the first question we did, it was like the one before this. I plugged x into x and I still got.
You plugged x into x. I don't understand what you mean.
Like,
You took your value for x?
and it worked.
Yeah. You can plug it into either one.
X and y?
No, just plug it in for x to find y.
So the top equation from the bottom.
I don't know if I'm following your.
Oh, wait, never mind.
Okay. Glad I could help. All right. Problems? All right, I got one more example for you then. Try this one. Then we'll be done. Either method, I don't care which one you want to use, solve that system, please.
It's y already -3.
The y-intercept is -3, but not the value of y. Okay. What method are you using, elimination or substitution? Yeah, substitution is probably easiest here because then you don't have to rearrange everything. But you could do elimination. You could move the 8x to the other side, line everything up, multiply by a number, add, get your values.
Can you see if I'm doing this right? Oh, no. I have to. And you put it in there. What? Why? Hold on, I'll be back.
Negative 6 doesn't equal 2.
Just one. Put it back in.
Because
No
they-
solution.
Did I screw up?
Yes. Yeah.
Oh, that, you didn't even skip a beat on that one. Jeez, we're gonna throw me under the bus. What did you get? What did you get? Why? All right, what's going on? Hold on. So if you did substitution, right?
Yeah.
So you took this and put it, you sure you put it in the right spot? Negative 16x plus 2 times the quantity 8x minus 3 is equal to negative 2. Am I okay so far? Negative 16x plus 16x minus 6, uh-oh.
Yeah, then you get 0.
If that's not true.
Holy guacamole. What does that mean?
No solution. Undefined.
They don't intersect, also known as? Two lines that don't intersect, parallel, correct. Okay, good, I want to make sure I'm pointing at the right person.
I did the elimination and I got 0 equals negative 8.
But you got a false statement.
Yeah.
Good. That's fine. You can do it a lot of different ways. As long as when you're done, you get a false statement. 2 things will happen in these weird cases. You'll get a false statement. Negative 6 does not equal negative 2. That means they're parallel. However, you could also see a problem where you get a true statement. The variables eliminate themselves and you have negative 3 equals negative 3. What would that mean? Yeah, they're the same line. Okay. Those don't happen very often, but I wanted to do one just so you understood what happens when that does occur. Okay? Problems? Day 6. Is that what we're on, day 6? Take the day off tomorrow. Thursday, we'll go over these problems and make sure you're solving these systems adequately enough, and then we're going to get some ugly numbers on Thursday. It'll be fun. Okay, you'll be using that fraction button a lot on your calculator.